for that.
So okay, let's get started then.
All right. I can go ahead and read the questions in part one. So it says, what is a confidence interval? Pretty much in like my own words, like, I don't know. Once you read the answer key, I kind of just feel like adopt the answer key answer, where it's like a confidence interval is an interval of numbers which estimate a population parameter.
Mm-hmm.
Yep.
What I try to do in my own words is just saying like confidence interval is the set, like the two numbers of where the population mean will coincide. But then once I read theirs, there seemed just a lot easier to say.
For me, the point estimate plus or minus the margin of error, right?
Yeah, plus or minus is the confidence interval. So number two is, what is the margin of error in a confidence interval when estimating the population mean? And so this question is not asking for the formula, but rather what length it represents in the confidence interval. Right?
Yep.
Yeah, it was kind of what you were just saying, the plus and minus, so it's the half. Question 3, assume you know the standard deviation. Isn't that what that is, that little symbol? Mm-hmm. What is the general What is this general formula for a confidence interval used to estimate the population mean? So that would be the simple term would be like the bar over x plus or minus m, and then m equals z with the o over the square root of n.
Yeah.
Okay. And then question 4. What are the assumptions for creating a confidence interval for a single mean with sigma known?
For one of so what I got was it has to be a simple random sample, normally distributed, and the sigma, it has to be assumed not to be, or assumed to be known.
Yeah.
Or it could also be a sample size is greater than 30, or 30 or greater. Okay.
Perfect. And then question 5, there's 4 parts to it. It says, open up your applet, but I guess we don't have to do that now since we already did it. This is type in 0.90 for the area, shade the middle area under below. This is record the positive z-score below the nearest hundredth. And that would be the one, let me pull up my answer.
0.6.
Yeah, the 1.645. And then the second one they wanted to do was 0.95, which then we know because of the reading, that's the 1.96. And then the third one is 0.99, which also in our reading put down the 2.57.
That one should be 2.604.
Oh, yeah?
What was that again?
That one should be 2.604.
At 2.576.
Same.
Hold on. I just accidentally X'd out of my paper sheet, so I have to open that back up. One of you guys can start reading. That's why I get that back up.
We're doing D now?
Yeah.
D of part 5.
Yeah.
So what happens when with the z-squared, the area in the middle under the line curve increases. So I got the z-squared increases.
Yep.
Yep. Sounds right.
Sounds right, but I thought it was not normal. Is that correct?
Okay, do you have it up, Daniel?
Yeah.
Part 2.
Yeah. Or oh, I only got one sheet. Let me get the other one up. Yeah, for some reason Microsoft kicked me out, so I'm trying to get all back on. All right, so part 2, question 6. What are the 3 assumptions that need to be checked before you compute a confidence interval for a mean? Of course, you always have to make sure that it's normally distributed, a simple random sample, and the sigma is soon to be known.
Yeah, same as question 4 in part 1.
Yeah,
Okay.
yeah, it's pretty much the same, exact same.
You know, last time we talked, we wondered about that sigma or the alpha being 0.01 or 0.05 or 0.1. Should it always be that? And I talked to Brother Bennett about that when I was going over my test. And he says it could be anything. Those are just the 3 most common, which actually talks about Nicholson. But he said he was doing some genetic study using a sigma of 0.00001. So it was kind of interesting. But, so it could be any of those. Just the 3 most common.
Gotcha.
Obviously, it becomes more accurate. But understand it better.
Perfect. So I'll read this little paragraph above what the rest of the questions are going to be answered by. It says the graduate management admission test is used as an admission criterion in many Masters of Business Administration programs. A BYU I professor would like to estimate the population mean from a simple random sample of 50 people's scores. The sample mean for these 50 students is 541. Assuming population standard deviation as 0 or O of 32, answer the following questions. What is the point estimate for the population mean? Answer that.
541.
Yeah, the 541. And then number 8, create a 95% confidence interval for the population mean. Show all your work. So the range, the low bound, high bound, or whatever they call it, I got the 532.13 and then 549.87.
Right.
And question 9, say that the sample size changes to n equals 100, and then just compute 95% confidence interval. So that calculation, what I got was a low of 534.728 and then a high of 547.272.
Yep.
Yep.
Exactly.
And then question 10, how does the margin of error for the 95% confidence interval of sample size 50 compare to the margin of error for the 95% confidence interval of sample size 100? The 50 interval was a lot wider.
Yeah, when the air gets smaller, when the sample size is larger.
Right.
Gotcha, yeah.
Right. So the margin here gets smaller, right?
Yeah, so when the number gets bigger, the margin gets smaller.
Right. Which makes sense.
And then question 11, create a 90% confidence interval for the original 50 students. The high and low I got there was 533.556 and then 548.444. And question 12, how does the margin of error for the 95% confidence interval that you computed in question 8 compare to the margin of error for the 90% confidence interval that you computed in question 11? And the answer that I put down there was that pretty much our error gets smaller as the level of confidence grows smaller.
Oh, yeah.
Mm-hmm.
I'm on 13, sorry.
Because you don't have to be like as accurate when it's smaller confidence.
Doesn't it kind of seem like though when the 90% of the margin of error would be higher? Maybe I'm thinking wrong.
Well, like
And margin error, oh,
when you make the margin of error higher, then you're widening the range out a lot more. So instead of being like,
Yeah,
oh,
no.
between 3 and 4, you're saying, oh, it's 2 and 5. And with that greater range creates a greater confidence of your decision.
Right.
But if you say, oh, it's between 2 and 3, no, it's actually 2.5 and 2.8, then you're like, there's a smaller, like, I don't know. It's kind of weird because at this you do that like with the narrowing of the margin happens when you have a larger sample size. But since there's a larger sample size, you can have more confidence that is that smaller range when it's a larger number. But if it's the same number, then it's like you have to lose that confidence when you go lower with the same number.
Yep, makes sense.
But then we're on the last question, right?
Yeah.
Okay.
Yeah.
Last question. The BYU-I professor would like to repeat the experiment, but he wants to make sure he has enough students in his sample to ensure that his margin of error is 5. How many students will need to be in his sample to ensure that he has this level of accuracy for a 95% confidence interval? And the answer I got was 158 students.
Right.
And did you guys use a formula to find this, or did you guess instead?
I used the formula that they gave us in the reading, which let me pull it up again.
It's that n equals z-score times standard deviation divided by n, and then square it all.
Yeah, that's the one.
I forgot to square it all once. So
4 times what?
So it's z times the standard deviation over the margin of error, and those are all in parentheses, and you'll square that result.
So the z times the standard deviation as well as the
No, so
Margin of
z.
error?
I'm gonna go ahead and try to type it in our little chat to see if I'll make it easier. Z times.
we use that when we're trying to find the specific margin of error.
Okay.
I'm almost done typing. I don't know how to input the symbols in here.
No, I got it. I found it.
Okay. All right. Cool.
Okay. Good.
All right. Perfect. Well, if we don't have any questions, we might as well just go ahead and start our quiz and stop the live feed.